Good afternoon, students. Uh, Good afternoon, students. I am Dr. Sundar, working as an assistant professor in the Department of Marine Engineering. In this video, I am going to present thermal efficiency of diesel cycle. You know that gas power cycles we have different types, auto cycle, diesel cycle, Brayton cycle and dual cycle. From that here I am going to present only diesel cycle for your reference. So what is a diesel cycle? Why it is called a diesel cycle? The diesel cycles, it was derived by Dr. Rudolf Diesel in 1893 from his idea to attain high thermal efficiency with a high compression ratio. So if you are going to see the auto cycle has low compression ratio compared to diesel cycle. So Dr. Rudolf Diesel invented to this cycle for increase the high thermal efficiency of the engine and high compression ratio. So you see, it is an important cycle and which all the diesel engines working based on this cycle. So this cycle is also called constant pressure cycle. Why it is called constant pressure cycle? Because there we have the heat is added. Because in our cycle the heat is received at constant pressure. So that's why it is called constant pressure cycle. So in these cycles we have four processes. Two reversible adiabatic or isentropic process, one constant pressure process and one constant volume process. So what is adiabatic or isentropic process? In this process there is no heat transfer either in or out. There is no heat transfer in this process. That's why it is called isentropic process. The remaining process, constant pressure means during this process the pressure should be constant. Constant volume process, during this process the volume should be constant. And these diesel engines are used in aircraft, automobiles, power generation, diesel electromotives and both surface ship and submarines. So these are the applications of diesel engine. Now we are going to see the classification of diesel engine. So normally we have two types of engine, the petrol and the diesel engine. So here the classification of diesel engine, we have two types. One is two-stroke diesel engine, another one is four-stroke diesel engine. What is the difference between two-stroke diesel engine and four-stroke diesel engine? In the two-stroke diesel engine, the complete process, the complete cycle within two movement of piston. The piston should be 2 times. It means that the crankshaft revolution is one revolution of crankshaft. It means two-stroke diesel engine. The four-stroke diesel engine we need for complete process 4 movement of piston. 4 times the movement of piston. It means that 2 revolution of crankshaft. That is the main difference between 2-stroke diesel engine and 4-stroke diesel engines. See, working of diesel cycle. So already I explained in the slide number 2, we have 4 processes. The process 1 to 2, isentropic compression. Process 2 to 3, constant pressure heat addition process or isobaric. Process 3 to 4, isentropic expansion process. Process 4 to 1, constant volume heat rejection process. See here, the first process is isentropic compression. During this process, the air fuel mixture, if you are going to take, here we are taking the diesel engine, so the air is separated, the fuel is separated. But in the auto cycles, petrol engine, the air fuel mixture is together. Here, during the compression, the air fuel mixture is compressed together. Next one, constant pressure process. In this process, we are adding the heat into the system. We are adding the heat into the system, that is called QS. Heat is supplied into the system. That is process 2 to 3. Then process 3 to 4, isentropic expansion process. It means that the air is expanded isentropically during this process. The process 4 to 1, constant volume heat rejection process. During this process, the heat will be rejected from the system. At the time, the volume should be constant. So these are the process in the diesel cycle. So now we are going to see the diagram. From the diagram, we can see how it will be operate. See the diagram, the first one, the PV diagram. It means that pressure volume diagram. TS diagram, temperature entropy diagram. So this is the PV and DS diagram for diesel cycle. See here, the process 1 to 2 W in means the work input, and 2 to 3 Q in, the heat is supplied, and 3 to 4 work output, the heat we will get output, the work output from the system. Then process 4 to 1, the heat is rejected from the system. So here we can able to see the process 2 to 3 constant pressure process. That's why it was indicated P2 is equal to P3, and process 4 to 1 constant volume process, V1 is equal to V4. Another diagram, TS diagram. See here, the temperature entropy diagram. Here we can able to see process 1 to 2 the same, but in this process we can able to see the temperature variation. The temperature is increases from 1 to 2, again 2 to 3, then the temperature will be decreases from 3 to 4, and again it will be increases from 4 to, again it is decreases from 4 to 1. So this is the BV and TS diagram for diesel cycle. So now we are going to see all the process one by one. Process 1 to 2. So here we can able to see isentropic compression. During this process, what will be happen? So what are the parameters are increasing, what are the parameters are decreasing? We can able to see from this PV and DS diagram. So here the isentropic compression. So in this process, the piston is moving from bottom dead center to top dead center, and compression of air takes place isentropically. It means that during the compression, the entropy remains constant. So it means that during the compression, the entropy remains constant. There is no flow of heat out of the cylinder wall happens. So here the air is compressed, so the process increases from, so that's why we kept our PV diagram and TS diagram in one slide. See, from the PV diagram we can able to see the process 1 to 2 isentropic compression. During this process, what will be happen? The pressure will be increased from P1 to P2. We can able to see P1 to P2. So next one, volume decreases from V1 to V2. Yeah, it's so in our BV diagram, x-axis we have volume, y-axis we have pressure. So in this process, the volume should be decreases from V1 to V2. Next we can see our TS diagram. It means that temperature entropy diagram. In that diagram, during the process 1 to 2, that is called isentropic compression, the temperature is increases from 1 to 2. At the same time, the entropy remains constant. You can able to see S1 is equal to S2. So there is no heat transfer. Next one, process 2 to 3. It means constant pressure heat addition process. So in this process, what will be happen? The hot body is kept in contact with the cylinder. So if you are going to see slide number 4, we have the cylinder setup diagram for diesel engine. So in this process, the hot body is kept in contact with the cylinder. The heat addition to the air takes place at constant pressure. So constant pressure means our process is 2 to 3. So during this process the piston should be rest for a moment at dotted center. The pressure remains constant. P2 is equal to P3. You can able to see our PV diagram. You can see our PV diagram. In that diagram, process 2 to 3 Q in. Otherwise it is called QS. QN means heat supplied, Q in heat input. Otherwise it is called QS, heat supplied. So here the volume increases from P2 to P3. We can see our x-axis. So the volume has been increased from V2 to V3. Now we can see our temperature entropy TS diagram. So temperature entropy diagram. So in that diagram the temperature is increases from T2 to T3. At the same time the entropy also increases from S2 to S3. This is our process number 2 to 3. Now we can able to see process 3 to 4. In this process, after heat addition, the expansion of air takes place isentropically and work is obtained from the system. So that's why it was indicated W out. So you can see our PV diagram. In that diagram, 3 to 4 process is isentropic expansion. So what they mentioned, the piston is moving downward during this process and reaches to BDC. So during this process what will happen? Already during the heat addition the piston is rest in the TDC. During this process what will happen? The piston is moving from top dead center to bottom dead center. At the same time the pressure decreases from P3 to P4, volume increases from V3 to V4. At the same time you can see our TS diagram, temperature entropy diagram. In that diagram also the temperature will be decreases from T3 to T4 and in this case entropy should be constant. Entropy should be constant. S3 is equal to S4. Now process 4 to 1, constant volume heat rejection or heat out, that it means Q out. So see our PV diagram, pressure volume diagram. So 4 to 1, heat is rejected. So during this process what will be happen? The piston rested PDC for a moment and the gold body is brought in contact with the cylinder and heat rejection takes place at constant volume. Heat rejection at constant volume. That's why this process is called constant volume heat rejection process. So in this process what will be happen? We can see our PV diagram. The pressure decreases from P4 to P1. Temperature also decreases from T4 to T1. Entropy decreases from S4 to S1 and volume remains constant. V1 is equal to V4 or V4 is equal to V1. So these are the process has been done in our diesel cycle. Now we are going to derive from this process. Now we are going to find out what is the thermal efficiency formula for diesel cycle. So we have to find out the thermal efficiency of diesel cycle. See the thermal efficiency. So the efficiency formula, normally the efficiency formula is equal to work done divided by heat supplied. So efficiency of diesel cycle is equal to work done divided by heat supplied. So now we can see what is heat supplied. So you can see our slide number 2 to slide number 7, the process 2 to 3. So during this process only the heat will be added. So what is the formula for heat supplied? So we can able to see in the slide number 10. So heat supplied, work done is equal to heat supplied minus heat rejected. So you can see, you have to see very careful. So now from this we are going to derive the efficiency of diesel cycle. Derivation is very important derivation. Okay, so you can see here the diesel work done divided by heat supplied. So what is the equation for heat supplied? Where is heat is added? That is called constant pressure process. So the formula for heat supplied, M, the kilogram of 1 kilogram of mass of air, M is equal to 1. Cp, what is Cp? Specific heat capacity at constant pressure. If it is mentioned Cp means specific heat capacity at constant pressure, Cv means specific heat capacity at constant volume. So it's a substance. The heat, what is the meaning of specific heat capacity? Specific heat capacity is a substance. The heat must be added in one unit mass of substance in order to cause to increase in 1 unit temperature. That is called specific heat capacity. So here we have two, Cp and Cv. Cp means specific heat capacity at constant pressure. Cv means specific heat capacity at constant volume. So heat supplied, where we applied heat, the process is 3 to 2. Isn't it? So you can see the diagram here. So that's why we kept PV and TS diagram in all the slide, because of the understanding. So if the diagram is not there, we can't able to understand. That's why I kept all the slides in these diagrams. Okay, you can see here, it's very important. The process 3 to 2, so or 2 to 3 is the constant pressure heat addition. So what will happen here? You can see M, mass, Cp, specific heat capacity at constant pressure, T3 minus T2. Why I kept here T3 minus T2? Why not T2 minus T3? Because the temperature, which one is higher temperature? We can see which one is higher temperature. Here we can able to see the T3 is the higher temperature. That's why we kept T3 minus T2. And minus M into Cv, constant volume process. Constant volume process where we have process 4 to 1. Process 4 to 1. See here we can able to see M into Cv, the higher temperature is T4, the lower temperature is T1. So if you are going to speak about temperature, suddenly you can see our TS diagram, temperature and entropy diagram. Okay, so you can able to see here 4 to 1, so T4 minus T1. Now we can substitute that work done value in that equation or in that formula. The formula has to be mentioned in our slide. Neta, efficiency of diesel is equal to work done divided by heat supply. So we have to substitute work done is equal to heat supplied minus heat rejected. So we have to substitute the values M into Cp T3 minus T2 minus M into Cv T4 minus T1. So here heat supplied M into Cp T3 minus T2. So here M is constant for all, so M cancel, and Cp T3 minus T2, that third step, the heat supplied M into Cp T3 minus T2 divided by M into Cp T3 minus T2. So both are same, so it has to cancel, minus M into Cv T4 minus T1 divided by M into Cp T3 minus T2. Here M is cancelled. So finally we will get 1 minus Cv by Cp into T4 minus T1 divided by T3 minus T2. So already we studied in engineering thermodynamics. What is the specific heat ratio? Specific heat ratio, it means that specific heat, it is the ratio of specific heat capacity at constant pressure divided by specific heat capacity at constant volume is equal to adiabatic index. It means gamma. Cp by Cv is equal to gamma. But in our equation we have Cv by Cp. So now automatically it comes 1 by gamma. So efficiency of diesel is equal to 1 minus T4 minus T1 divided by gamma into T3 minus T2. The above equation is the efficiency of diesel cycle in terms of temperature ratio. It is very important because in our equation eta diesel is equal to 1 minus T4 minus T1 divided by gamma into T3 minus T2. Here we have only temperature values. So this equation is related with temperature ratio. Now we are going to find out another efficiency values for diesel cycles in terms of volume ratio. So this is our temperature ratio value for diesel cycle efficiency value. Now we are going to find out the efficiency for diesel cycle in terms of volume ratio. See here, this is very important. Already we explained that slide process 1 to 2, 2 to 3, 3 to 4. Again one time I have to explain. So you can see our diagram. The diagram is very important. So PV and TS diagram also mentioned in this slide. During this process, pressure increases from P1 to P2. So see our diagram, PV diagram, and the process 1 to 2. So what will happen? Process 1 to 2, the pressure will be increases from P1 to P2. And you can see our TS diagram, process 1 to 2, here also temperature is increases from T1 to T2. But in PV diagram, during the process 1 to 2, the volume should be decreases from V1 to V2. I hope you understood. Because by using the diagram only, we wrote everything here. So we can see if for derivation, for this derivation, the PV and TS diagram is very important. You can see, already you studied in engineering thermodynamics, the pressure volume temperature relation. So what is the relationship between pressure and volume? What is the relationship between temperature and volume? Here we are using the relationship between temperature and volume. So T2 by T1, why we are taking here T2 by T1? Because our process is 1 to 2. So you can see here 1 to 2, which one is higher temperature? T2 is the higher temperature. So I am mentioning here T2 by T1 is equal to V1 by V2 power gamma minus 1. So when the temperature is increases, at that time the volume should be decreases. That is the meaning of T2 by T1 is equal to V1 by V2 power gamma minus 1. So you can see if you are going to find out T2, automatically T1 is goes that direction. That's it. So T2 is equal to T1 into V1 divided by V2 power gamma minus 1. So now we can see what is compression ratio. That is very important in this derivation, compression ratio. So initially I told the diesel cycle was invented for why they invented this cycle? Because of the high efficiency and high compression ratio, isn't it? So here we can able to see compression ratio V1 by V2 is equal to R. So the compression ratio, what is the definition for compression ratio? How we have to find out compression ratio in the cylinder? So the total cylinder, the total volume of the cylinder divided by the clearance volume, that is the compression ratio. So total cylinder volume, it means that septal volume plus clearance volume divided by clearance volume. So V1 means the total cylinder volume. V2 means the clearance volume. So compression ratio is equal to, it is the ratio of total volume of the cylinder to the clearance volume of the cylinder is equal to R. So here we can able to put T2 is equal to T1. Already we have V1 by V2. We have to replace that value by using R. So T2 is equal to T1 into R power gamma minus 1. So this is our process 1 to 2. You have to assume this is our equation number 2. Equation number 1, the efficiency of diesel is equal to 1 minus T4 minus T1 divided by gamma into T3 minus T2. Now, process 2 to 3, constant pressure heat addition process. During this process, pressure should be constant. So already we know in this process the pressure should be constant. P2 is equal to P3. The volume increases. You can see 2 to 3. You can see our PV diagram. 2 to 3, process 2 to 3. Volume increases from V2 to V3. Temperature increases from T2 to T3 in TS diagram. Entropy increases from S2 to S3 in TS diagram. So by using this, we can able to write V by T. So the pressure is constant means volume divided by temperature is equal to V by T is equal to constant. So our process is 2 to 3. So we have to put 2 and 3. V2 by T2 is equal to V3 by T3. So if we are going to find out T3, then we will get T3 is equal to V3 into T2 divided by V2. So now T3 is equal to V3 by V2 into T2. See 3, 2. So here rho is equal to V3 by V2. It means that cutoff ratio. What is cutoff ratio? So volume V3. So volume V3 means at the end of the heat addition process to the beginning of the heat addition process. It means cutoff ratio. Another one meaning it means that during the combustion process, how much fuel is injected into the system, that is called cutoff ratio. During the combustion process, during the combustion process, how much fuel is injected into the system, that is called cutoff ratio. See here, T3, the previous slide you can be able to see T3 is equal to V3 by V2 into T2. So you can able to see now we have to replace the value V3 by V2. V3 by V2 is equal to rho. So we can substitute that value in this equation. So T3 is equal to rho into T2. Rho into T2. And we know that value T2 is equal to what? T2 is equal to T1 into R power gamma minus 1. T2 is equal to T1 into R power gamma minus 1. So we can substitute that value in this equation V3 by V2 into T2. So T1 into R power gamma minus 1 into rho. This is our equation number 3. So now we are going to process 3 to 4. 3 to 4 it means that isentropic expansion process. During this process, pressure decreases from P3 to P4. You can see our PV diagram. So pressure has been reduced from P3 to P4. Temperature also decreases from 3 to 4. Volume increases from V3 to V4. Entropy remains constant. S3 to S4. See here the PVT relation, pressure volume temperature relation. Here we are using temperature and volume relation. So here is highest temperature is T4. So T4 by T3 is equal to V3 by V4 power gamma minus 1. This is the relationship between temperature and volume. So this is the standard formula. Okay. So it's a gamma minus 1. So adiabatic index. It means that adiabatic index or isentropic index. Gamma means isentropic index. So now we can calculate V3 by V4. We can take V3 by V4 is equal to, as we know, we can able to write this form like this. V3 by V4 is equal to V3 by V2 into V2 by V4. So here we can able to see V3 by V2 already we know rho into V2 by V4. V4 is equal to what? We can check our process 4 to 1. V4 is equal to V1. So we have to replace the value V4 into V1. So V2 by V1. So V2 by V1 means what? V1 by V2 is equal to compression ratio. Already we know V1 by V2 is equal to compression ratio. So now we have V2 by V1. So we have to put 1 by R. So V3 by V4 is equal to rho divided by R. So now we have to substitute this value into the equation number 4. Substitute V3 by V4 value in equation number 4. What is the equation number 4? T4 by T3 is equal to P3 by V4 power gamma minus 1. So now we can substitute the value T4 by T3 is equal to B3 by B4. What is the value? Rho by R power gamma minus 1. Now we can calculate T4 is equal to T3 into rho divided by R into rho divided by R power gamma minus 1. You can see T4 is equal to T3. So what is the value for T3? T3 is equal to, you can see our equation number 3. Now we can substitute equation number 3 value in this equation. T4 is equal to T3. We have to replace the value T3. What is the value for T3? Rho into T1 into R power gamma minus 1. So we have to substitute this value here. So rho into T1 into R power gamma minus 1 into rho divided by R power gamma minus 1. So you can see here rho, so here R power gamma minus 1. So R power gamma minus 1 cancel and the remaining values rho into T1 rho power gamma minus 1. So in our power rho we have plus 1 value and another one we have rho power gamma minus 1. So plus 1 and minus 1 cancel. So finally we will get T4 is equal to rho power gamma into T1. Otherwise we have to write T4 is equal to T1 into rho power gamma. This is our equation number 5. Now already we have the equation number 1. So now we have to substitute T2, T3 and T4 values in equation number 1. So we can see our equation number 1. So equation number 1, this is our equation number 1. So 1 minus T4 minus T1 divided by gamma into T3 minus T2. We have to substitute T4, T2, T3 and T4 value in this equation. We can able to see here. We have to substitute all the values. 1 minus. So T4, T1 into rho power gamma. T4 minus T1 divided by. What is the value for T3? T3 is equal to now we can see T3. So T3 is equal to rho into T1 into R power gamma minus 1. R power gamma minus 1. So before that in that equation we have the gamma minus T3 and minus T2. T2 is equal to T1 into R power gamma minus 1. So efficiency neta is equal to 1 minus T4 minus T1. T4 what is the value? T1 into rho power gamma divided by gamma already we have in the equation. So gamma into T3. What is the value for T3? Rho into T1 into R power gamma minus 1 minus T2. T1 into R power gamma minus 1. So if you are going to take T1 out, we will get the top. We will get T1 into rho power gamma minus 1 divided by gamma into T1. T1 cancel. Rho into R power gamma minus 1 minus R power gamma minus 1. Now we have to take R power gamma minus 1 is common. So what is the value? 1 minus rho power gamma minus 1 divided by gamma into R power gamma minus 1 into rho power minus 1. So now we can able to write this is our efficiency of diesel cycle equation. So finally we have to write it like this. Efficiency of diesel is equal to 1 minus 1 divided by gamma. Gamma means adiabatic index into R. R means compression ratio power gamma minus 1. For air gamma is equal to 1.4 into rho power gamma. Rho means cutoff ratio minus 1 divided by rho minus 1. So this is the equation for efficiency of diesel cycle in terms of volume ratio. So I hope the students are understood this one. Now I can explain for advantages and disadvantages and finally application, then I have to complete my presentation. So now what is the advantages of diesel engine? It is very high efficiency. Yeah, it is very high efficiency, high thermal efficiency compared to other engines, and greater torque. Greater torque, it means that we will get a higher output, higher torque output from these engines, and it is durable because of the combustion process. It is a very durable one, and it is a good resale value also. These are the advantages of diesel engine. What are the disadvantages? It is more expensive to purchase compared to other engine. And another one is fuel is pricey. It's a little bit is high and less accessible, and finally it has higher maintenance cost. So if it is a diesel engine, the maintenance cost is high. So we have to, these are the disadvantages of diesel engines. Now we are going for applications. What are the applications? We are using diesel engine in diesel generators, locomotive. Normally the locomotive they are using steam, electric and diesel. So diesel engine, diesel locomotive also they are using in the railway sector. And in the farming equipments, some of the farming equipments we are using the diesel engines, and in construction works we are using auto equipments. So some equipments we are using our diesel engines. In cargo and cruise ships also we are using our diesel engines. And finally in the buses and trucks also we are using our diesel engines. So thank you for watching our presentation. Thank you.